Hi, this is Vijay. In this video, I'm explaining about what is static part, and there is a load balancing controls like deployment, replication controller, replica set, stateful set. These are our load balancing controls. Okay, coming to the static parts. Okay, let me see what are the static parts. These static parts are placed in system namespace. Every control plane components can be run as a pods. You want to see the kubectl, get all -n cube system. API, what are the control plane components? API server, controller, okay, scheduler, controller and manager, scheduler, etcd. These all are running as a network. These are running as pods. Okay, these pods are managed by the kubelet. The API server cannot control the static pods. The kubelet can take care of static pods. Okay, the kubelet only can take care of these parts. These are our static parts. These static parts having the control plane components. Okay, every control plane component can be run as a static part. Okay, suppose if there is any part is deleted or crashed, the kubelet will take care of a deleted part and recreate it. Recreate it. Let me delete one static part. Okay, use it here. Delete pod name. I'm just taking Kube API, okay, this pod, okay, the pod got deleted. -n cube system, okay, the pod got deleted, and again it will create it by kubelet. Okay, you can see that the API server will recreate it. This task will manage by the kubelet. You have one idea. You have one doubt, not idea. There is no replication controller, there is no replica set, there is no deployment. How it is recreated again? That means kubelet can take care of control these pods. These are control plane components. API server cannot handle these pods. So that's why in normal pods can handle by the API. These pods are handled by the kubelet. So if something is goes wrong with the control plane components, the kubelet will, what is the function of kubelet is? Kubelet is an agent. It is continuously monitoring the health checks of the cluster. Okay, health checks of the objects in the Kubernetes cluster. That's it. So we have one doubt. Can we create applications normal pod in static pod location? These static pod located in TC Kubernetes manifest. Let me clear the screen. Yeah, this is the directory. This directory kubelet keep etcd. It is a etcd ML file, kube API server ML file. These are the configuration files for creating control plane components. Okay, if we deleted these ML file, we cannot create it. Okay, so every time kubelet comes to this path and using this ml files and create manifest file. Create by using these pod manifest file to create control plane components. This is about the static parts. In general, in real time, we are not doing these things. We are not deleting the control plane components parts. So uh, we may not get access. That means we are having only limited access to the Kubernetes cluster based on policies. Okay. Okay. In general, come to the normal parts. I have yesterday in last class I have created one part that is working. Let me show you. This is IP of the part. This is port number of part. It is working. I'm using Tomcat's web application. So if you can get on my mobile to see the complete details of the Tomcat service. This is 30986. This port number. This IP is version IP of the node worker node. Okay. Here in normal parts, can we delete the part after deleting part? Is it recreated without applying the control plane? And means replication control replicas daemon set stateful set. It is not possible. Okay, let me show you. It's it here. If we hit the command, the control plane, there is no control plane here, so the part got deleted. Okay, the pod life cycle is we are not directly created pods in general, but the controller, the controller can create the pod because pod is ephemeral. Okay, the control plane can handle the pod life cycle. Okay, there are stateful set replications, replica set, replication controller, deployment, daemon set. These are our control plane components. Sorry, these are not control plane components. These are our replication controllers. Okay, without replication controller, the part not to be rescheduled. Okay, what is a replication controller? Let me show you. Here, there are these are our deployment um, workload resources. Okay, the deployment replica set, stateful sets, daemon sets. I already told you. Now I'm explaining about replication control. Okay, for the replication control, how to write the ML file. Okay, in kubectl API. Before that, we need to check the resources of our replication controller. You can see the version, resource request, replica set. Yeah, replication controls. Okay, the short form is RC. The version is V1. Okay, coming to that, the manifest file model. Okay, API version is V1. Kind, what kind? Replication controller. The metadata is identify the objects. If we mention with the help of metadata to identify the objects. Okay, name of the replication controller name, namespace. This is the namespace. If you want to give the namespace, okay, in which namespace the application controller can run. Okay, and spec, coming to that, spec is replication controller specifications. Okay, and here we mentioned replicas. How many replicas do you want to maintain? Just mentioned here. How replication control can identify the parts by using selectors, labels and selectors. Okay. In the selector, I will give the key value of pod label value. Okay. Okay. I will explain in the next ML file. I will explain clearly before running the ML file. Okay. This is template. This what template we are using here? It is pod template. That means whenever we are creating the parts, we mention the value, API version, name of the part, namespace, specifications. These are our part templates. These part templates are coming to the picture. Templates, these are part templates. And the part templates, metadata for identifying the part, name of the part, the label of the part we just give. Here, part name. Yeah, after part name, there is if we update with namespace, the application control cannot identify this, so no need to update. So then labels and selectors by using labels and selectors for identifying the parts, labels, key value. Okay, these are and then after part specifications and under part of creating container. Okay, creating containers name, image, port, image name, port, container port. This is about the part manifest file. Okay, and we need to add service for accessing part from outside. Okay, accessing container from outside. Okay, API version. So this is another example. API version. So this is API version. This is service. The kind is service for accessing part from outside, from accessing container from outside. Okay, the name of the service, namespace, in under which namespace, specifications, service specifications type, it is notebook. Previously, if you mentioned cluster IP for internal cluster communication, cluster IP is used. For accessing outside, we're using notebook selector. Here also tables and selector comes to the picture for identifying parts. Maven web app name I have just mentioned. Okay, it's a port number, ports. The service port number is 80. Whatever you are giving the number also no problem. This is target port is a container port. Okay, after that node port we can give or not. If you are skipping that node port, Kubernetes will give the port number, which is range between 30,000 to 35,605. Okay, this is about the ML file. Okay, I just have created one ML file here. This is one ML file for application controller. Here you can see that application the version is v1 kind application controller metadata name is tomcat under which namespace are you creating replication controller. This is test-ns. I have created in past. Okay, this is replication controller specifications. This is the replicas number of replicas mentioned. If we mentioned we can scale up later, we can scale up the replicas also. Initially I mentioned only one. And this is a selector. Selector means labels and selectors for identifying the parts. Okay, tomcat web app. Okay, template and metadata. These are part templates. Labels comes to the picture. These two. This is part label. The selector identify the part. The replication controller identify the parts by using selector. These selector must be matched with the this one. Okay, under specifications. This is container specifications, container name and name which name of the container and where you pull the image from where this is my docker hub.docker account, so I have given here this is port, this is container port. Okay, I have taken Alpine image. Okay, come to the service, we need to provide access to the expose services to the parts. Okay, in the cluster out from outside. Okay, kind service metadata Private by objects, name, Tomcat SVC, namespace, tester type in NS. It wouldn't have created here, I mentioned here. Specific of service type node port, the selector. These labels are selectors come to feature app Tomcat, okay. The ports, service port is 80, target port is 8080. The target port is must be same as container port. Now I'm running that ML file. Service already created. kubectl get all hyphen go wide hyphen n. I've created in test.ns service. So that's why created his part, only one part, because I have mentioned in here, I mentioned only one part. So it is creating only one part, okay. The part we can access from outside is created in on the worker node. His port number is 30738. Let us access from outside. 135 it was created in 135 what IP 135, sir. I think it is created in. Let us check where it is created. Yeah, this node. So I copied it and port number 30738. Oh, okay. Here you can able to access. Okay, I'm intentionally delete the part. What will happen? Okay, you sit here, delete part name. Here I will explain the name of the part. Okay, why we get the ID after part name. Okay, and hyphen n, just hyphen ns. Okay, I'm just deleting the part and checking whether it is working or not. It may not available sometime, but sometime. Okay, the controller, the replication controller will create the part. Okay, again, okay, with different name. In past, the idea of the pod is 9CWBX. Here, this is changed. Okay, why it got changed? Because Kubernetes will give the pod name. Okay, if you use replication controller, Kubernetes will give the under pod templates. We are not giving the name of the pod. Okay, if we give the name, the replication control will ignore. That's why the replication controller will give the ID of the pod. Okay, that's it. Yeah, now I am scaling up the application, scaling up the pod, okay, by using imperative way, kubectl scale pod name, okay, hyphen replicas equal to, suppose I'm giving two, oh sorry, hyphen n, there's one command, let me check, scale up the RC, kubectl scale RC, replication one, hyphen replicas scale RC, sorry, I'm giving the scale pod, not RC. So that's why it is showing a scale RC. Oh, sorry, replication controller name kubectl scale RC and replication controller name. Okay, hyphen replicas equal to, I'm just giving two, sorry, in which namespace, yeah, the podcast scale. Okay, let me check kubectl get all hyphen go wide get parts also. You can see get parts hyphen n test hyphen ns. You can see the here that what other product got created. This is an imperative way. In declarative way, you can edit the manifest file and update with the replicas. Okay, you can change. This is about the replication control. Okay, and replica set, there is a another more another control replication control is replicas and another load balancing controller. The replica set is the next generation of replication controls. The only difference between a replica set and replication control, right now is the selector support. Okay, replica set support the new set based selectors requirement as described in the labels user guide. Whereas in replication control only supports equally based select requirements. I will give the demonstration in next video regarding replica set. This is about in this session. I have explained only static parts, which is used by the control plane components, and replication control for normal parts. That's it. Thank you.